This is the Swedish NLP seminar. My name is Magnus Holgen. I will be the moderator today. And for today's seminar, we actually have the speaker with us on site here at the AI Sweden office in Stockholm. And we're really happy to present Yoav Goldberg as our presenter here today. Yoav is a professor at Bar Ilan University in Israel. And you're also research director at the Ilan Institute in Israel, right?
Yes.
Yeah. Yoav has been active in many areas of natural language processing. I know Yoav's work primarily in the word embedding field, but I think other people might know him from dependency-based aspects of work. But I think my favorite paper, or at least the paper that I spent most time reading and thinking about, is a paper I read this summer, and I spent an unreasonable amount of time thinking about that paper. We have already talked about that. It's a paper called Provable Limitations of Learning or Acquiring Meaning from Ungrounded Form, right?
Mm-hmm.
Yeah. But sadly, this presentation today will not be about that paper. Today we're going to hear about language understanding benchmarks and evaluations. And with that, I leave the word to you.
Thanks. It's great to be here. Thanks for having me. It was a great morning. I've learned a lot of things. It was very interesting. I think what I will talk to now will not relate to any of that. It's a different topic altogether, but I hope it will be interesting. It's also not about word embeddings and not about dependencies. So it's like a different thing, but I hope it's interesting. It's a work that I personally kind of think is one of the kind of most important that I did over the past few years. But I actually never actually gave this talk in this format. So I hope it will be a good first run on it. And I hope it will be interesting. I don't really know how much time it will take. I think it will be fine. And my personal kind of tendency is to, if you want to ask questions doing it, kind of feel free. But if you do otherwise here, then it's also okay if you don't. But like I'm fine with like interruption. I also don't really take note of time, but I'll try to. And it's like if I'm really kind of running overhead, let me know. And with that, let me start. So this work, reading between the lines. Better benchmark for text understanding. It's in collaboration with Yanai and Vika and Reut. We've been working on this project for quite some time. It was like a long project, mostly long to conceptualize. And I would say that, okay, the kind of main topic, I'll start with this question, what does it mean to understand language at all? Right, and that's what I kind of maybe talk in this presentation, but this is not how this work started. So we kind of started from a very applied kind of thing, which I still find very interesting. So basically this work has two kind of legs. One of them is something very applied, very useful in NLP, and the other, okay, maybe we can actually use it to kind of measure understanding. And this talk would be around how to kind of use it to kind of measure understanding or like why it's good. But there is an applied side to it, which I'll touch at the end. Okay. So now before we kind of begin, kind of disclaimer, I will not talk about models or modeling or like neural networks. I just don't find them very interesting these days. Just because, you know, modeling transformers, they work, make them larger, they work better. You can say more, but like not like, I think it's enough for that. And also, as I said, what I asked like before, what does it mean to understand language? That's kind of like philosophical question, and we have different answers, and that's one kind of way to look at this research. But also, as I said, the motivation for this work comes from a kind of much more like practical background, and I think it's good to have both things. Okay, and also I would say that the kind of motivation came from this other project that I'm kind of very heavily involved in, where the goal is to effectively put NLP capabilities into the hands of experts, but not in NLP or CS. So like someone from science, from medicine, from the kind of humanities, someone who kind of wants to do something with text, in my case, with like large collection of text, right? But they don't have expertise in machine learning. They don't know how to program. How do we kind of make it good for them? And for that, we need to kind of solve like various problems to kind of do it right. And I will talk about that project in Uppsala on Friday if you want to kind of catch it. But that's also a kind of a very large motivation behind this work. So the works are not yet integrated, but hopefully they will be not so distant in the future. So I had this project about how to effectively put NLP in the hands of blah, blah, blah. And its kind of main like product is this like software called Spike, which I will not talk about much now. I just like briefly mention that it's a kind of search-based system that does both search and extraction together and allows for like text mining experiments. It has like rich queries over large corpora, which is indexed with symbolic structures. And that's where the kind of connection to what I'll talk about now begins, because we need these kind of symbolic structures. And then if we kind of need them for indexing, like what should they be, right? And that's part of the kind of motivation for this project. Okay, now we can begin the actual talk of this. So as I said, what does it mean to understand language? Okay, big question. Maybe simplify a bit. What does it mean to understand text? Okay, so it's like not only text. And okay, text is also very broad. So let's say more than a sentence, less than a book. Okay, so no, longish text, not too long. A document or less. Okay, and then you can ask, okay, so what does NLP community think about understanding, okay, or like comprehending, right? So you can see this survey here from 2 years ago, roughly, right? So it's a survey of like comprehension, right? And if you look at the abstract, right, you can just like read it. So there are 60 machine reading data sets. So the NLP community has a lot of effort into this kind of benchmarking comprehension, right? So, okay, and if you kind of read more, okay, then we categorize data sets according to the question and answer form and look at the first question word, and then why, when, where, okay? So basically, all of those efforts seem to revolve around question answering. Okay, so the answer basically seems to be understanding text is the ability to answer questions about the text. Okay, and I think that's kind of very common for the kind of NLP community at large, right? If you understand something, then you can answer questions about it, right? And I think this is actually true. If you understand, then you can answer question. The other way, I'm not sure if it's so true, right? If you answer a question, do you understand? And that's, well, maybe not so much, okay? But okay, so there is this, like for example, like squad data set, right? So that's a QA data set where basically you have a passage and a question, and some span over the passage answers this question. And the model has to basically getting the passage and the question mark the right span, right? And you see that humans do relatively well and machines do better than humans, which is a bit surprising. I mean, I wouldn't argue that machines understand better than humans, but they do better. So we actually do quite well on that. Right? And then you can ask, okay, does squad understand? Or maybe these people are a bit lazy. What's going on here, right? But okay. So now my question would be, is QA a good format for measuring machine text understanding? And then my answer would be not really, and let me tell you why. But before that, a small digression. Again, I kind of like these kind of digressions. So is squad like QA really at human level, right? Or like above? And I say, okay, also not really. And now I just want to kind of highlight some things that we found about like squad abilities, right? So what we do here is using this Spike system from the other project, we'll collect certain cells, okay, based on some pattern-based query. Okay, so we are looking for the pattern, some chemical treats some disease, right, in the kind of syntax form. and then we get a bunch of sentences that basically look like that, right? So some chemical or some kind of NER mistake, which treats some like some disease, right? And we can kind of extract many of these as pairs. And actually we get like 346 like of these kind of cases from a large-ish corpora. And of course, if you do a different pattern, chemical is used in the treatment of, right? Then you'll get many more examples. So like not all patterns are equally like likely. So some have like better recall than others, but still, I mean, these things kind of effectively work and get stuff, but not very flexible. So now, okay, now let's see what QA does, right? So we have these examples, and here are the kind of results for the chemical treats disease case, right? And then you basically apply a kind of QA model over them, right? And you ask Squad, now train on like Roberto Lab, which is kind of good. You basically ask it which chemical treats a disease, right? For each of these sentences. And you see over here, right, that it managed to kind of like find some of them, but also if you look over here, you see that you have many no answer cases. So basically Squad says this question has no answer in this sentence, even though we know that they do, because like some of them are really easy, right? Or like, for example, like this one is very easy, and also this one, right? And somehow Squad did not find an answer here, which I find surprising or like a bit disturbing, but just like to kind of let you know the truth. Of course, there is some threshold here, and if I can kind of make it like a bit lower, then it will find an answer, but then it will also find very bad answer somewhere else, right? Because here, like everything has an answer very clearly with the pattern, and some Squad misses that. Okay, so Squad fails in practice on many cases, even easy to find one. So it's really kind of, but if you just use it, then it works pretty well. But if you kind of just like try something a bit more methodical, you see that it fails, which is kind of surprising. And this kind of gives you, I think, like for me, it kind of gave a new intuition on the kind of limits of like machine learning. So usually you say that, okay, symbolic has low recall, and like neural has like better recall. And I think it's true in one sense, but not overall. So basically, I think symbolic methods are not very diverse. So they have like low recall in diversity, but they are exhaustive, right? If you have a pattern, they'll find this pattern, right? While neural methods are like very diverse, but as we see, they are not very exhaustive. Okay, so that's just to say, I think there should be a way to kind of combine these two worlds, okay, and get something which is both diverse and exhaustive, right? And we are now looking into that. So that was the kind of digression. So Squad QA models don't work as well as advertised, at least like in some cases. I think there are like ways around that, but yeah, they should be just done. Okay, now back from the digression. So we were asking, is QA a good format for measuring machine text understanding? And again, I would say not really. And now let's see why, okay? So what's the problem with QA for like measuring text understanding? So here there is this passage, a kind of short one about protests in Iran. Not these protests, like ones from like 8 years ago, I think, still protests in Iran. And then you can have like QA. And so like if you ask who is the president of Iran, the model can answer it without the text, right? So you don't really need this kind of text to answer, because it's some kind of like word knowledge, right? So you may be able to understand or to kind of answer this question without answering the text, just like not related. And also models can actually use similarity pretty well, right? So if I ask who were allowed to be enlisted into the armed forces, right, and it sees this like pattern over here, right? It will find the answer even though it doesn't really understand. It's by like pattern matching without any paraphrasing and so on. And you can say, okay, so let's create like better tests, but that's hard, right? Paraphrasing question away from the text is actually very hard. And if you want to do it via annotation and like without like leaving hints, it's even harder, right? So I don't think we have a kind of good way to do that, right? So like, so telling a person, ask a question about this text without using words from this text, very hard. Like they're kind of really bad at that. And also, as I said, they kind of leave hints where I think I had, okay, never mind. And also there are shortcuts and heuristics that models can take, also people do. Okay, so here is an example. Okay, so where did they protest and when did the protest take place? Right, okay, you need to kind of read to understand, but really you can say, okay, where? There's only one location here. So where is enough to answer this correctly, right? Unless you ask something about which is like not in sex at all, like where did I buy flour yesterday? And then the kind of model should say like no answer, but it might also kind of say yes, right? So it's really hard to kind of find things like with no hints like that, or to kind of isolate hints from understanding. Similarly, when, okay, only one time here, that's probably the answer. And people do that too, right? Like when kids have tests, yeah, they do that, right? So yeah. And then on the other way, there is this kind of ambiguity. So if you ask who were expelled, okay, so it could be students, these students, like students who protested, students who tested about, so like various spans can actually fit this, right? And the data has some tendency of like what the kind of right span should be. And that's actually where models are better than humans, right? Because the kind of person doesn't really know what the right span is, and they're all good, so they kind of measure something. And the model kind of knows what the kind of test expects. And that's basically where models get better than humans. I think they're better at like the kind of actual span predictions, not more than that. Okay. So all of this goes to say QA measures understanding of the text and the question together. Okay, not only the text, right? And the issue here is that the kind of question provides extra information, okay, which kind of makes things much easier. And if the question is authored by a human on the text, right, when seeing both, there are like even more hints, and we have like one paper on that, where basically if you know who the annotator is for this question, you get better at answering it a bit, right? So even like knowing, like people leave hints when they write questions, that they have their own style and so on. And there was also like follow-up work, and yeah, so it's really hard to kind of produce bias-free kind of data sets, right? So basically, when you do QA, you provide tons of hints, either from the question or from its style, of like what you ask about and so on. So you don't really measure understanding, you measure how well do you understand the question, right? And then answer it, which is different than the text itself. Okay, and now we can kind of look into that again and kind of in a more, I guess, informed way, or like more critical look, and like, is it really understanding or something else going on here? Okay, so that was kind of the motivation and intro. And now, okay, so what would be a better text understanding benchmark, right? So as I said, QA measure text and question together. And what we would like to do is maybe develop some test that relies on the text, on all the text, but nothing but the text. So like, I don't need like extra information there. So like no extra hints if possible. Okay, and also desirable, we would like to be able to do annotation at scale by non-expert without introducing human biases, if we can, okay, which is not easy to do. And now I don't need this thing to be cheap, I just need to be possible, right? I mean, I can invest time, I can invest money, that's fine. I just want it to be possible and get like good results. Okay, so now let's look at what Wikipedia says about text comprehension, and we'll be lazy and we'll only read the kind of beginning of that. And basically it says, integrate with what the reader already knows, right? So you kind of read text and you kind of integrate and like build some worldview, and we take a simplistic view into that. Okay, so I kind of like simplify, and we'll ask, can we track relation between entities as we read? Or even not as we read, just like all the entities, can we track how they can relate to each other? Okay, and I think if we can do that well, then we sort of understood something at least, right? And I'm not saying that this is the best measure, but it's better than QA. Okay, that's where we stand, and even I think like much better than QA. Okay, so as we read a text, we build this network of relation between entities. And the question is like, can a machine recover this network? And as I said, I think this network is also of some very like practical utility. So if we can do it, we both understand and we can do useful stuff with it. Okay, so form relation between entities. So here I have the kind of text from before, and all of the entities are kind of marked in orange lines underneath them. Okay, and some relations have been tackled in NLP before. NLP has a lot to do with like relations between stuff. And like one of them is like coreference, right? So what's coreference is basically the is same as relation, or like point to the same thing relation, right? So for example, we need to identify that students and these students in this text is the same entity, right? Or that the president and Ahmadinejad are the same entity, and the kind of university in its various names is the kind of same thing, and the kind of chancellor and this person are the same, and so on. Okay, so that's like one relation between entities. They point to the same thing in the world, right? And that's okay, that's useful to recover. I would argue that if a model can do that, it understands the text reasonably well, or at least like some aspect. And then the other thing that kind of is very prominent in NLP, SRL, semantic role labeling, okay, is basically take its relation between entities which are mediated with verbs. Okay, so there is some verb, some predicate, for example, like visited, and like this, like visited combines or like connects between the person who visited, where they visited, and like when, right? So so like visited ties together, right, these three entities. And similar enlisted into, right? So like students enlisted into armed forces. Okay, so relations which are mediated via verbs, as I said, they are very common and they're very useful, right? Though doing annotation for SRL is not very easy, but people like recently came up with this notion of QA-SRL, which is a way to do crowdsourceable SRL, also with no ontology, but like based on question. And the kind of main idea there is that for each verb in the text, identify its arguments and ask questions about it. Right, and these are like so like for like visited, who visited someone, where did someone visit, when did someone visit, right? So basically, turn these kind of roles of the arguments into basically like question answer pair, right? And this thing is in a way crowdsourceable and kind of useful to do. This was pioneered by Julian Michael and Luke Zettelmeyer, but there is a lot of follow-up work at Bar Ilan led by Ido Dagan into kind of making it like first making it kind of more robust, but also making it from like verbs to other phenomena like adjectives and so on. right? And they kind of call it QA SEM. Now that's also QA. So you may ask, okay, how does it relate to kind of QA-based understanding? I would argue that this is better than QA because it could be exhaustive, right? So for all the verbs, you ask all the questions, right? It's much better than kind of just like coming up with a question, but still it gives you hints, right? Because if for like visited, you ask who visited, then it kind of gives you a hint like of like where to look. So it's still not that kind of exhaustive, but also very useful. Okay, so we've seen coreference, which is the same as relation or points to the same thing relation. And we're seeing like semantic roles, which is basically relations that are via verbs. And we can ask, is there some other category that we of relations that we can find? And the answer is, of course. In linguistics and in NLP, people have identified many kinds of relations that are not these ones. So for example, nominal SRL, bridging like various kinds of them, arguments of like relational nouns, and so on. There are like many of these. The problem here is that there are many of these. Okay, and they all somehow kind of relate, but they are different. So it's kind of like fragmented. They are kind of hard to define. You ask one linguist about bridging, you get one answer. They'll argue with the other linguist, like, is this a bridge or not? What kind of bridge is that? And so on. The boundaries are fuzzy to both linguists and, of course, to non-linguists. So it's really hard to kind of work with these. So they kind of identified some kind of very deep relation, but then they start to kind of fight about how to categorize them and what they mean exactly and what's really the kind of boundaries. And then everything get lost because you have like thousands of like very small data sets, each for a different angle of like one phenomena, kind of really hard to kind of work with. And we were kind of looking for something which is a bit more unified and maybe even, you know, less precise, but more easy to explain and maybe kind of more general than these things, right? Because like none of these caught on as a kind of task in NLP because it's not easy to define as coref. Like coref, you kind of explain to someone and they understand. That's nice. Now bridging, you try to say, okay, that's not, and people get lost, right? So we wanted something which is kind of a bit more unified. And now finally, I get to our solution after, okay, so that's our kind of criteria. So we wanted a kind of relation type between nouns, which is kind of frequently occurring. So something that can happen a lot, not like every once in a while. It should be non-trivial to recover, or at least some cases should be non-trivial to recover. It should be useful to recover. Right, and that it can be easily defined and explained to non-linguists for two reasons, right? So first, I want people to understand what it is, and I want people to kind of understand why it's useful, right? And if I can explain these two things, maybe people will actually use it, right? And also, it could be both crowdsourceable and useful. Okay, so I wanted to kind of be able to kind of explain it maybe to crowd workers, but also to actual users of this thing. And coincidentally, this will correlate with a nice benchmark for understanding. Okay, but that's like what we were trying to do. And our solution, we try to focus on relations which are mediated with prepositions. Okay, so these are like small words such as in, on, under, with, against, okay, things like that. And like some of these are explicit. Okay, so here we have like signature of the chancellor. Okay, so it's actually expressed in the text with this proposition. Okay, that's easy to recover. But many of them are not explicit, right? There could be, but they are not, right? So you could write that students at the American University protested something, but you didn't write it. Okay, it's assumed that that it's there, but nonetheless, this relation exists. Okay, so there is a relation between students and the university, which says it's students of or at the university. And it's from Iran, against the kind of president, right? So it's not there explicitly, but it's behind the scenes, and it's a true relation. Okay, so these are the ones that we target. Okay, and I would say that people recover these relations naturally as they read without noticing. Right, so it's not something that you say, okay, now I want to kind of understand. You just like read and say, oh, these students are at the university. Well, it's trivial to you, right? You do it based on word knowledge. You do it based on how the kind of word behaves. You do it based on expectations, maybe based on the structure of the text, right? Many different reasons for you to build this map of like of what relates to what. And you do it also for coreference and also for like Israel, but also for that, right? You just don't really verbalize it because it's kind of very obvious to you. Okay. So I think that recovering these relations, okay, is a core understanding task. Okay, that people do automatically. Okay, so in a larger context, I would say that most information in text is implicit. It's not stated like directly. And recovering that requires reading like between the lines, but humans do it very naturally and almost subconsciously, right? So if you ask someone, is there something missing here? They say no, like all that thing is here because I can recover it when I read. Right, but it's not really there. Like for a computer, it's not really there. Maybe GPT-3 can recover this. I didn't try well enough, but my suspicion is that it's not great. Like it can do some of them, but not great. I also don't really know how to prompt it to kind of get it because the prompt can leak information. Right, so even if I say students off, okay, it will kind of do something, right? But how do I kind of know if it understood this connection without me asking it what I want to know? That's a bit tricky, but it's good to kind of think about. Okay, and we also work on other implicit phenomena now, but in this project we kind of focus about these like relations that are mediated with prepositions. And like I said, some of them are explicit, some are implicit, and we, by definition, did not want to separate them. We said we want everything. If it's like written there, it's really fine. If it's not, also fine. We just want all of them together because we want to have a simple definition, right? So basically, we give you all of the base NPs in the text that we kind of found based on some like heuristic, and you, for each pair, need to decide, is there a kind of relation between them and which one? Okay, so that's the task. Okay, so we have this text-based NP enrichment task. That's the name. Not a great name. We, if you have a better one, do let me know. We are still looking, but that's the name. And basically, as I said, the input is a text and a list of entity spans over the text. Okay, so it's literally the text and no real new info, only boundaries. Okay, and the output is for each of the almost n squared pairs. Okay, so text-based NP enrichment, the input is a list of entity spans, and the output is that for each of the almost n squared entity pairs, we have the list of propositions that could connect them, and this could be empty if there is no connection, right? And there are many no connection cases, but also many cases when there is a connection. Now, some things to kind of note about this task, it's natural text. There is nothing here that's really like human output, right? So the kind of humans said if there is a connection, but they didn't kind of provide extra information. It's a kind of large set. So like we need everything, not someone that like someone thought is important, but all of the connection. I think it's very important. It's hard to cheat with heuristics, and the answers are mostly unambiguous, right? So maybe the kind of human like forgot one or two, that happens, right? So there is some ambiguity there. Maybe there are like various like different propositions. So basically, you can say on or at, right? And maybe both would fit in this context, and people may only confuse one of them. But that's, I think, a kind of small amount of ambiguity. Definitely, if you kind of compare it to QA kind of like setups. And it's online. Now, if you go to this website, there is this kind of link at the bottom. You'll see the paper. It has like more detail in how we kind of did it and so on, like why, useful to read. There's also this explore data where you can see our kind of data set, right? And like if you look at that, so basically you have the text. Actually, I think it's on the slide. So you have the kind of text over here. It's longish. It's not very long, but it's based on Wikinews, and it's basically 3 paragraphs and a title, which is quite a lot. You get all the NPs on the side, based again on this like heuristic that we kind of extracted, the spacey and like chunking and so on. You have Horev chains over here. So basically we say which entities are the same. So that's like extra thing that we did. And most importantly, on the side, if you click on an entity, you see all of its relations that were identified. And this is interesting data, kind of rich. Okay, if you do download, okay, so we have a train, dev, and test. Dev and test were kind of collected later than train, so they are more accurate, I guess, because the annotators are more trained, basically. And also we have like out of distribution test, which is basically different domains. So movie dialogues and like Reddit forums, which is different than like we can use. And overall, we have like 5,000 documents and around 10,000 paragraphs, or even a bit more, and roughly 1 million NP relations, which is a lot. It was a huge annotation effort, very time-consuming to do, but it's done now, and I think it's like very interesting data to look at. We also have a leaderboard. It's not very exhaustive yet. We only had like our own like baseline, and some students who tried in a course to kind of beat it, a course in a different place in Tel Aviv University. And they tried quite hard to do it, and the results are not that good. Of course, you can do better maybe, but still there is this like big gap. So the human agreement on the F1 label task is like 94%, which is kind of high for agreement. And the models do like 56, right? So they are much worse. Again, these are not the best models. It's our baseline, which are kind of best effort and like students in the course, but still, I mean, people try to do it, and the obvious things don't work very well, right? Can you do better? I hope so, because I kind of want it to be solved. So it's both a benchmark and something that I actually want to solve. So by all means, try and improve that, right? If you can do it with like GPT-3, great. I don't know how, but great. Okay. So as I said, what does it mean to understand text? Our answer would be being able to kind of recover relations between all of the entities in the text. Okay, and this could be coreference, SRL, and our new thing, which is proposition, which I argue is harder than the other ones because like many of them are really implicit and not specified. Okay, we have a better RC benchmark. I think question answering is a poor setup for like measuring text understanding. We argue that recovering relations with propositions is much better. It's a natural, comprehensive, hard, and useful task. And there is data and leaderboard, so you can try it out. Now, before I begin, before I end, I also mentioned like utility, right? And I didn't really discuss that. So now let's say a bit about why it's useful, okay, to do it, okay? So it's useful because then we have machines that understand, great, but what can actually do with it? Okay, so if you take this text, first expulsion, so it's expulsion of students from university by someone, and it's all written there. And it's student at university against this person, so it's also kind of written. And now, once you do that, you can basically delete this, right? And have all of your information about the sentence in a kind of more self-contained form, right? So you make things which are implicit, you make them explicit. You make global relations of the document local to this like sentence, and you make the sentence standalone, which is better for indexing and for querying, right? It's much easier to kind of index one sentence than a paragraph. And when you query, you want all of the kind of information to be in the same place, because this kind of relates these things together. So some other example, okay, so in our other project, we have this question, okay, so what are causes of some medical condition, right? And then you kind of read the kind of literature and you see the sentence, typical causes include, okay, but causes of what, right? And if we had this thing that says, okay, causes of sciatica, then we can actually have this like similar pattern that will extract this, but it's not implicit, it's not there, it's implicit, right? So again, if you make global things local, it will solve this issue. In some other examples, so we had, or like there is this sort of morbid but common, or like desired use case, find cases of people shot by police, right? And then you have this text, which is kind of elaborate, and then it ends up by leading to his fatal shooting. But nowhere is it said that like a police shot a person. Right now, if you do this task to the end, you will get that it's shooting of some person by police of some department, right? And then again, you can make everything kind of like self-contained, and now everything is. So basically, we make things which were implicit into being explicit, and we kind of make it local to the sentence, and we can index and query and so on. Of course, we are not there yet. It's really hard to kind of make these models, but if we could, I argue it to be like very useful for these things. So that's the end. To conclude, a new task, which I think is foundational, which is to recover all original relations between entities in the text. It's well-defined and easy to explain. Okay, it's natural, comprehensive, hard, and useful. It makes global thing, it makes global and implicit things local and explicit. And I think it can improve AI abilities while also being useful, which these things are not always correlated, right? And there is dataset and leaderboard, so do try it out. I'll take questions now. Thank you.